Our project develops a self-managing vertical farm aquaponic greenhouse using an Arduino Uno on TKCAD. The system automatically controls water, heat, and light through sensors and actuators. A soil moisture sensor activates a pump when irrigation is needed. A temperature sensor monitors water temperature with LED alerts, and a photoresistor controls (LDR) about when natural light is low. So, by applying structured programming, the system creates an automated efficient environment that supports healthy plant and fish growth through real-time decision. Hi, today I'm going to talk through the project of my aquaponic greenhouse system. So first, when the system starts, it is on setup, which is initialize serial communications, so that we can see data from the serial monitor. The next one, we will set up the pin modes for the sensor and the actuator, and we will initialize the LCD display and show a welcome message to let the user know the system is working. Next, we will read the sensor, which is temperature from pin A0, the soil moisture from pin A1, the light intensity LDR from pin A2. Once we get the readings from the sensor, then we will process the data. First, we will convert the temperature to Celsius, and the next one, we will turn the soil moisture into a percentage, and the last one, we will calculate the light intensity percentage from the LDR sensor. Next, after we calculate the value, we will print the temperature, soil moisture, and LDR values to the serial monitor, so we can see them in real time. We will display the temperature and soil moisture on the LCD screen for the user to check it quickly. After that, the system calls three control functions, which is control RGB LED, control motor, and control bulb. Let's talk about how the system uses the RGB LED to show the temperature. If the temperature is below 25 degrees Celsius, the LED will turn yellow, meaning it's cool. And if the temperature is between 25 to 35 degrees Celsius, the LED will turn orange, indicating it's the perfect range for plants. And the last one, if the temperature is above 35 degrees Celsius, the LED will turn red, and the buzzer will turn on to one that it's too hot. Next, let's take a look on the motor control. If moisture is less than or equal to 20%, the pump runs at full speed, which is 255 to the water plants. If the moisture is between 20 to 50%, the pump runs at half speed, which is 128. And if the moisture is above 50%, the pump will stop since the soil is wet enough. And the last one, let's take a look on the bulb control. If the LDR value is 30% or lower, the grow light turns on because the greenhouse is too dark. And if the LDR value is above 30%, the grow light turns off because there's enough natural light. Once all that's done, the system takes 1 second delay before starting the loop again and checking everything from the beginning. It repeats the process, continuously adjusting the conditions based on the sensor readings. So that's how the system works.
Today, I will explain the list of components used in our Arduino Smart System. First, we have three input sensors. The temperature sensor connected to pin A0, measure from 0 to 50 degrees Celsius. Secondly, the soil moisture sensor on pin A1 monitor. Monitor soil wetness from 0 to 100%. Next, the LDR light sensor on pin A2 measure ambient light level from 10 to 1000 lux. For the output device, we have a DC motor water pump connected to digital pin 3. This pump can operate in on or off mode and also support PWM speed control. We also use a buzzer on pin 5 that functions as a simple alert system. Next, we have an RGB LED consisting of 3 color channels. The red LED on pin 13 is set to 2.2 volts, the blue LED on pin 12 and the green LED on pin 7 both run at 3.4 volts. We also include a grow light bulb control through digital pin 7, which turn on or off depending on light condition. To display information, we use a 16 by 2 LCD screen with I2C communication connected to the SDA and SCL pin F4 and A5. Finally, our system is powered by a 5-volt power supply.
Hi, so for today I'm going to explain about how our Arduino code works. So the first time, we start by including the LCD library so that the Arduino can control the 16x2 LCD screen. So we use hashtag include _liquid crystal.h. Then we define all the sensors and actuators. So for the analog sensors, we use temp_sensor for A0 to read temperature, soil moisture sensor A1 to read soil moisture, and light sensor A2 to read light level. For the actuators, we use motor 3 for water pump and buzzer 5 for alarm for high temperature. Then we also use RGB LED. The red one is for pin 13 and the blue one pin 12, and last one green pin 11. So for the grow light, use bulb, which is pin 7. Then we create an LCD object to send text to the 16x2 display. So we use _liquid crystal LCD0. After that, we also declare the variables to store readings and calculate values such as raw temperature reading, light percentage, soil moisture percentage, calculated voltage, and the last one is temperature in Celsius. So these variables are used inside the loop. The next step, we also set up functions runs once when the system turns on. So for serial monitor, we use serial.begin 9600. Sensor inputs, all sensor are set as input. And the actuator outputs, we have pump, buzzer, bulb, and RGB LED pins. All of them are set as output. The next one is the loop function. This is where the system runs continuously. All the system that we used before will run again and again until the end. So the first step for this loop, it reads sensors. So for example, the temperature, raw analog value, soil moisture, raw value, and light converted from sensor value to percentage. Then step 2 for this loop, we convert the values. So for temperature conversion, we convert from analog value to voltage, and convert from voltage to Celsius. And the step 3, we also use serial monitor output. It displays the temperature, soil moisture, and light levels for debugging. Step 4, LCD output. The first line is the temperature and the second line is the soil moisture. This gives real information to users with a laptop. Step 5, actuator controls. This is where the 3 main functions are called. The first function is control RGB LED. The second one is control motor, and the last one is control bulb. And the last step is delay. We use delay 1000, so it runs the systems every 1 second. So to conclude, from the top to bottom, this code reads sensor data, process it, display it on the LCD, and then automatically controls the pump, the grow light, the RGB indicators, and the buzzer to maintain ideal conditions for an aquaponic greenhouse. So that's all. Thank you.
So, our team uses the three main sensors and four main outputs. The sensors are the temperature sensor, soil moisture sensor, and a light sensor, which is the photoresistor sensor. The outputs are the DC water pump motor, a bulb, a buzzer, and the RGB LED. Now, I will show you a quick demonstration. You can see the serial monitor displaying the current sensor readings. Let's break down how each part functions. First, the temperature control. If the temperature is below 24 degrees Celsius, the RGB LED will change to the yellow color. Alright, so if it's between 24 degrees Celsius and 35 degrees Celsius, the LED will turn to orange color. Okay, 28 degrees Celsius, orange color of LED. And if it goes above 35 degrees Celsius, the LED turns red and the buzzer sounds an alarm to indicate a critical high temperature. Next, the soil moisture sensor that will control and automates the watering. If the soil is too dry, below 20%, the water pump motor runs at fast speed. So, below 20%, 0, the motor runs at fast speed. Okay. At a moderate moisture level, between 20% and 50%, the motor runs at a slow speed. So you can see, runs at slow speed. And if the soil is wet enough, above 50%, the motor turns off completely to avoid overwatering. The motor stops. Finally, the light control system. When the ambient light level falls below 20%, it automatically turns a bulb on. So, currently, the light level is below 20%. Once the light level goes above 20%, the system turns the bulb off. This acts like an automatic night light or a simple lighting control system. So the bulb is off.
For the conclusion, the project successfully demonstrated an automated vertical farm aquaponic greenhouse using Arduino and simulation tools like Tinkercad. Sensor and actuators were integrated to monitor and control temperature, humidity, water level, irrigation, ventilation, and water circulation. Structured programming techniques were applied to produce clean, modular, and well-documented C++ code. The system effectively used real-time sensor data to make decisions that maintain stable environmental conditions for both plant and fish. Safety feature and user feedback mechanism (LED) alarm display enhance the reliability and usability of the system. The project shows how automation can improve sustainability, reduce manual labor, and increase efficiency in modern vertical farming and aquaponic operation. Overall, the work highlights the potential of automated greenhouse systems in supporting smart and sustainable agricultural practices.